Howdy folks, this is part 3 of how to handle and work with algorithms. In the first two parts we talked about how to really read the algorithm prompt and then how to actually figure out what the algorithm does. In this part we're going to talk about how to figure out how to translate what we did into computer instructions. And this can be a little complicated, but it's still very formulaic, like a lot of this stuff, so hopefully we'll get through it. Let's get into it. So looking back at our original prompt here, toSum. This was our algorithm, okay? Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. This is kind of how we came up with it. First, we look at the first number, compare it to all the other numbers, add them. If it's 9, we found it. Move on to the second number. At that point, we kind of, but then we move on. This would be, okay, third would be -2. Compare all the numbers past 11 or past -2. Add them, or any 9. And then let's just kind of go on and do the fourth. Okay. Fourth, 6. Compare all numbers past 6. And you can see all I've done here is just extrapolate past, assuming we didn't find it when we compared that 11 and 2. What would we have done? 5, 11, 2, and 6. So looking at this immediately, what I see is that I basically did the same thing over and over again. And there's a reason I wrote it this way, so that that's apparent. That's why if you notice yourself doing multiple steps over and over again, make it clear to yourself that, okay, and then I went back and I'm going to do the same exact thing, but starting from a different place in the array or object, etc., because it can really help you with that. That is a loop. First, second, third, fourth. Okay, so I'm just going to start off and say, loop over all numbers as num. This is pseudocode. Pseudocode basically is not real code, but it's structured like code. It looks like code. You can see that's a loop, clearly, looping over all numbers as number, kind of like if this is JavaScript. Maybe I should turn this into JavaScript. It would be for num of numbers. Right? However you want to write this is totally up to you. That's the beauty of pseudocode. It can really be whatever you want as long as you understand the steps. It's pseudocode, it's not real code. Now, I'm just going to grab this in here and just kind of make that more generic, right? So in here, I've got actual specific numbers in here. 5, 5, 11, 11, 9, -2. That's specific to this example. I want to come up with a generic list of steps that would work for any example. Okay, so loop all over numbers as num, compare to all numbers past num, and add them, are any 9. This is not generic. This is the specific target I got, so are any target. Found it. Compare to all other numbers past num and add them. This is a little more subtle. If I want to compare to all other numbers past num, let's look at this. For 5, what would that be? Just put that in parentheses here. 2, 8, oh, you know what? Let's use our second example. 11, -2, and 6. Okay, past 11. What's past 11? That's going to be -2 and 6. You might see the pattern already. This is 6, and this is just empty. Well, what is that? That's just a slowly shrinking. That's this array, basically, starting at this, whatever our position is, +1, and all the numbers in that. I want to take 5 and compare it to all 3 of these, 11 to all 2 of these, -2 to 6, and 6 to nothing. That's another loop. Because I'm doing it to all of these, that's just another loop. So we're going to say loop over all numbers past num as num2. There could be a lot of ways to do this. Usually you'd have an index and you just have like for j equals I plus 1. Right? Now, this gets even simpler because that's this whole thing. Add them. Or any target. Okay, we know how to add them, right? This is what I would call an atomic operation. I don't need to break this down. And this is the trick when you're taking your steps and turning them into pseudocode. If you have these on a single line and you don't know how to do this line, like you don't know immediately how to turn that into code, it needs to be broken down further. Like this. Do you know immediately how to turn that into code? Maybe not, right? Are any target, We found it. Okay, well, let's check that. What is any our target? If, add them, let's just say sum equals add them. If sum equals target. We found it. That's easier, right? That's a very clear statement that we know how to code. What is we found it? We found the indices. Return indices of num and num2. All right. So we loop over all of our numbers. We loop over all of our numbers again past num. We add them together. If that sum is our target, we return the 2 indices. This should be code that you should be able to do. If there's any part of this you don't know how to do, that might be because my pseudocode isn't clear enough for you. Try this on your own, see what you come up with. You might want to say, okay, loop alt as num using I as index and using j as index, and then you say return ij. Right? That's a little bit more clear because now we know which index it is. I wouldn't need that if I was writing pseudocode because I kind of am just keeping track. Oh, I have an indice. You might need that, and that's okay. That's totally okay. So here's our pseudocode. All right. This is an important step, but it's not super difficult because eventually your steps, it becomes pretty obvious. Let's try this with palindrome number. This is the other example that we were looking at. Okay, so let's say we have 1, 2, 3, 2, 1. How do I know it's a palindrome? So if I write out that previous, I'm going to quickly go through the exercise we did last video. Start with 1. First number 1, compare to last number 1. Next number 2, compare to second to last number 2. And then next number 3, middle, always equal. Cool, let's do another one. 1, 2, 3, 3, 2, 1. I did this because I can just copy these 2 steps. It's the same thing. Next, number 3, compare to, what is this? Third to last number 3. They're all equal. So here, what are we doing? We're starting with 1 and 1, 2 and 2, 3. 1 and 1, 2 and 2, 3 and 3. So we're starting on both ends and we're slowly working our way in. Okay, so we go from 1, we go from 2, we go from 3. This kind of seems like another loop, but a loop that's only running through half. Okay, so if we want to do a loop for that, let's say loop from 0 to half length of number. How do we get that? We don't need to worry about that right now, but I know I only want to go through half the number. In this case, I actually want to say half number rounded up. Why? Because half of 5 is 2.5. Rounded up, it's 3. I want to go through the first 3 positions. See? Because I need to compare this middle. This one, if it's even, it divides nicely. That's just something you can know about palindromes. If you were working through this on yourself, that's probably something you would figure out. I just happen to know that, so I remember that from palindromes. There's little pieces of knowledge that can be helpful here too. So what are we doing? Num is length. Oops, number. Num is. I want to actually, because I'm trying to figure out how to describe this. I want to say like nth digit of number, right? Because this gets complicated as n with index n. Okay, I'm clearly saying my index because I got to do a complicated bit of math here. This is not. How do I get num2? How do I get the second number? Well, if it's 1, this is going to be the last one. If it's 2, it's going to be second to last. If it's going to be 3, it's third to last. So every time I advance here, I kind of go down on this one. So whatever I'm going to do, the number of places I go down is equal to the number of places I've gone up, which is n. So if I start at my end, what is this? What is 1? 1 is at position 5 here, right? 2 is at position 4, 3 is at position 3. So if I start here, I've got position 0 to position 5. Position 1 to position 4, which is 5 minus 1. Position 3 to position 4. Position 2 to position 4, which is, I've lost freaking count. Let's write this out. So you can see how this gets complicated. 1 is at position 0, and its corresponding position is at position 5. Okay, 2, it is at 1 to 4. 3, it is at 2, which goes to 3. Right, okay, so that's why. 3 is 2. So every time we basically take our first position here, and we subtract whatever our I is, and that's how we end up with what our second position is. That is actually going to be, it's going to be length of number minus 1 minus n. Why minus 1? Because this length of number is 6. And we got to start off at 5. So that means length of number, okay, that's going to be 6 minus 1 minus n. 6 minus 1 minus n. 6 minus 1 minus n. And there you go. This gives us 5, this gives us 4, this gives us 3. This is just something that kind of is useful to remember because of that offset by 1, or that the fact that arrays start at 0. But that's our digit of number. There are better ways to write this. That's kind of confusing. I could say is the digit of number at index. Right. Okay, cool. Now we've got our two things. Now we say, okay, what next? We compare them. Compare, so if num is num2, what happens if num is num2? Well, we're good. Continue. All right. Now here's where things get a little interesting. We know from code that loops continue normally anyway. We actually want to exit if these aren't equal. So I want to actually flip this as not num2, return false. That's actually real JavaScript right there. That's okay. You can put real code in your pseudocode for situations like this because it's clear what's going on there. So loop from 0 to half length of number. You know what? That's actually really confusing. I'm going to say round. Actually, I'm going to use ceiling here of number.length divided by 2. I'm just going to put in a little bit of, again, code in here because for me, this is actually easier to read than writing out that whole description of the number, length of the number divided by 2 taken to the ceiling or rounded up, right? That's kind of actually hard for me to read. This is easier. So it is, like I said, it's okay to put stuff that looks more like code in your pseudocode. It's totally up to you. What is easier for you? This is for you to read. Okay, num is the digit of number at index n. Just rewrite that a little bit. This one's a little complicated, but we kind of figured that out. And you see, we did a little sleuthing. We looked at what our steps were and figured what are we doing here? And this really differs between algorithms. You'll find little pieces that are the same, but really it depends on what your algorithm is to kind of figure this stuff out and glean your information. Okay, it's not 2. And so there we go. There's our pseudocode. All right, so this is a complicated step. I know we spent a little bit more time on this. I know I told you, well, the hardest step is actually going from here to your steps. This is the hardest step for you right now, going from these steps to the pseudocode. This is systematic, though. This is going to become easier. The more you practice, it's just going to start becoming easier and easier, and eventually you'll just get these steps and you'll just write straight code, and you won't even have to do pseudocode. For now, this is hard, but this is the thing that gets a lot easier very quickly as you improve the skill. Figuring out the steps of the algorithm, that does get easier, but it takes longer for it to get easier. Right? So that becomes a little bit more difficult. And so definitely practice this whole thing, but this is why, like, focus on this part, because this part comes a little bit easier. Alrighty, folks. I hope this is helpful. I'll see you all next time.